Many people know that standards like ATSC 3.0 and 5G broadcasts can disperse live events like live TV channels or live audio streams very efficiently, but did you know that they can also send more than just live information? They can also send non-real-time data using something called caching. This type of caching over an internet protocol multicast link is handled with data carousels. With data carousels, you're sending the same file over and over again for a certain amount of time, so that mathematically, any receivers that are in range and want to receive the file can receive it. Now, this file can be anything. It could be a website, it could be video on demand, audio on demand, like podcasts, you name it. If it's on the internet, it could be sent with ATSC 3.0 or 5G broadcast. Then what would happen is either on your device's RAM or internal storage will be a collection of cached files that you've subscribed to, meaning that your device has selectively chosen to allow certain files to be saved on your device that is relevant to you without the need for an internet connection and without the need of requesting data from a server. Any relevant files that you're willing to add to your device would be saved via Internet Protocol Multicast using one of these standards. Now, if you've ever heard the terminology broadcast internet thrown around, this is how broadcast internet is implemented. Not necessarily with an upload connection or an uplink connection, but with caching and data carousels. One of the applications that I've brought up frequently on this YouTube channel has been caching the most frequently visited Wikipedia articles to devices that are in range of a wireless internet protocol multicast broadcast. That way, you wouldn't even need an internet connection, and you would have the statistically most viewed Wikipedia articles updated in real time on your phone without ever needing an internet connection. This not only makes data transmission extremely efficient since it's only being sent out once, but this is also using a fraction of the amount of power. And as a rule of thumb, the fastest way to access data is data that's already on your device, that doesn't need to go through an entire internet network and without having to request those files from a server every single time that you wanted to access them. If it's already on your RAM or if it's already in your internal storage, you will have near instant load times. This is just one scenario out of potentially millions of different scenarios that could coexist with this technology. A major scenario that the actual broadcast industry is pushing for right now is to deliver software updates with their broadcast transmissions, because software updates are very large files nowadays, and it would be way more efficient and cheaper for the vendors that have to get their software updates out if it was sent over a one-to-many model. To give you an idea, one of the use cases already being deployed with some ATSC 3.0 broadcasts right now is caching the images of the stations. So with WTVJ in Miami, Florida, they have images of all of the various channels in the channel guide, and those images are being sent via caching with data carousels. In my interview with the co-founders of iGolgi, Dr. Ramaswamy talked in great detail about the technicalities of data carousels, which are fundamental to this technology working. Here's part of the interview. If you guys want to get into data carousels at all, I think that would be a very interesting topic that a lot of people don't fully understand.
So one of the challenges of broadcast itself, right, is one-way broadcast. So a lot of times for data, unlike video or unlike other audio or video, data needs to be error-free. The challenge of making something error-free is, in a broadcast world, especially when you don't have feedback, so you can do one of two things. You can put what is called matrix. There's many ways of coding the data so that even if you had error in one block, you can use an adjacent block to error correct it. You can do what is called fountain codes, which are like a way to progressively correct errors as you go along. There are many techniques that people have developed to do one-way broadcast carousels so that the endpoints can over time correct for errors that because there will be errors, because going over the air, there will be errors due to interference, due to, multipath, whatever. So these errors can be corrected if you had, and you build a set of tools to do your error correction. So data carouseling, one of the challenges with data carouseling is that if all these tools that you put in place to do the error correction in of a particular block failed, you want to get another swipe of the at the data later on, because you can't have any errors. Essentially, if you're trying to do a software update, for example, you have to have an error-free reception. Only then you can use that block of data. Otherwise, the block of data is useless, right? Until you are able to fill it in with a corrected error block. And by the way, the correction is constantly monitored by all kinds of redundancy checks, one and two dimensional, and so forth. So the challenge with data carouseling, and this is something that many people have not quite gotten their grip into, is that the capacity of doing data carouseling is a function of where you are in the infrastructure. Like, for example, carouseling in Phoenix would be much simpler than carouseling in Utah, for the very reason that in Phoenix, everybody is like, it's a flat infrastructures. Put up an antenna, you'll receive it pretty reliably. Unless there is a bunch of interferers, you're in great shape. You go to Utah, I mean, which is nearby, not too far off, hilly terrain, half the time you miss data, especially if you're mobile, you miss a lot of data. And so carouseling means you have to have many more, the carouseling parameters have to be completely changed. So the throughput, right, of carousel data on broadcast changes depending on where you are. And so that's one of the biggest challenges for planners, for people who are planning, like, let's say if Tesla says, I'm going to do a software update across the country using a data carousel from ATSC3, the challenge that they have in a broadcast infrastructure is they'll cover 89, 90% of the population in Phoenix, but only 60 for the same carousel parameters in Utah. So then the question is, what do they do? So for Utah, they would have to do the carousel over many more times, which means that it is less efficient. And so this is one of the biggest challenges of broadcast carouseling as an application. There are other carouseling applications where it's easier to do, like distribution of education content and all, because those are regional. So they can tune them regionally. But whenever you have a national application, it becomes a lot more challenging.
So would you say that as a rule of thumb, if the area becomes trickier, you lower the modulation and code rate to make it more
Absolutely.
robust and then
Then
make it
you
go longer?
So you have the two handles, right? You can lower the modulation coding rate, which means your throughput goes down. And so you'll
Hmm.
have to do lesser number of carousels to get your 100% coverage. Or you say, I'm going to carousel it more time. I'm going to leave the modulation the higher, and then I'm going to carousel it more time. A third alternative is that anyway, cell phones have a return path. They may go and fetch the missing data over a back channel somehow. I mean, they can do that too. So there is software that is being developed to do both, all of the above. And so overall, right, the robustness of adding these software layers on top to make sure you get 100% reception of all the data is the biggest challenge. And a lot of companies have spent a lot of time doing this. It's not a trivial problem, especially when you're trying to solve it for a broad set of geographies with very, very different conditions.
Yeah, and with software, you can ensure that when it does display as a full complete file on the device, that it is like
It
error
is
free.
it is error free. Yes.
I mean, that's what, coding algorithms are for, to
Sure.
make sure that,
Sure.
if there were any errors, it rejects the whole file, or if it's done in segments, that it, rips out that segment and waits for it again.
Sure. Wait for the
So it's
carousel.
not like, oh man, if I do data casting, it's going to be this file that's going to brick my
Oh,
software
no.
device,
Yeah.
And some people have that, perception like, oh, it's just unstable. It's UDP. It's just gonna, and it's like, no, at the application layer, it's gonna go through
Absolutely.
and ensure that that file is, the
Right.
quality is there.
And it is getting it over, like I said, the carousel. There is your three handles, right? The modulation coding parameter, like you said, they can just
Yeah.
that can automatically be adjusted to improve reception. The number of times you carousel something, and then on top of that, you do all kinds of CRC checks and everything, and you have a back channel. If you needed to go back and fetch a segment on a back channel, which is low cost because you have done only a small segment, you can do that
Yeah.
in addition. And so tools are there to do all of the above. So
And two, with ATSC 3.0, there's also, spatial multiplexing. There's MIMO.
mhm.
There's layered division multiplexing. So you can in turn allocate more data capacity
Sure.
to, your data carousel than you normally would with a SISO or without, multiple services without a layered approach.
Yeah. Yeah.
So, that's a great thing as well. It's like, oh man, if I make it robust, I'm not gonna, you could double your data capacity if it's robust
By doing
with
MIMO. Yeah.
MIMO. or ensure that you're getting the full data capacity with that tier with LDM with just a small impediment on the receive SNR. So it's
Yeah,
it's it's a great standard for that, and I think that's one of the things that 5G broadcast doesn't have on
that is
ATSC
true.
3.0
That
is
is true.
LDM.
Speaking of 5G versus ATSC3, you're absolutely right. ATSC3 is slightly better designed for doing broadcast carouseling. I totally, I mean, this is something that was by design, actually. People from
Yeah,
day one decided that they wanted to do that. The only flip side of the whole story is the 5G world. I mean, the infrastructure, especially the not only the phone infrastructure, but also phone infrastructure with an extension to receive UHF, but also the transmit infrastructure. So imagine that all the cell phone base stations now all of a sudden can become 5G transmitter sites with
yeah,
a small modification. The 3G using the ATSC infrastructure is slightly stymied in terms of the number of, where the infrastructure lies, right? The overall, how it overlays the geographies is very different than what the cell phone infrastructure is, which is one of the reasons why 5G, if it has the right, I mean, it is slightly less efficient than ATSC3 for those kinds of broadcast carouseling applications. But the thing that works in its favor is this head-end infrastructure, and also the fact that phones can be modified a little bit more easily. I'm not saying it's easily, but it can be done. That's one of the things that it has working in its favor.
yeah.